The purpose of this video is to give just a slight recap of the topic of limits. To start off with, when we're talking about a limit, the way that we're going to think about it in this course is simply the idea that the limit of f of x as x approaches the value c is going to equal the value L if we can make f of x as close to L as we like by making x sufficiently close to c. And I reference on either side here, in a moment we'll talk about the notion of approaching along the x-axis either from the left or the right. But the important thing is we're not talking about what happens exactly at the value c, but just what happens as we get very close to that. The notation that we're going to use is LIM for limit. Underneath that, we're going to indicate what value the input is approaching, and what we're taking the limit of is f of x, and then L we're saying is the value of that limit. And we're going to see some examples where we say that the limit does not exist if we can't find such a value L. So to start off with, I have a few functions here. So if you consider the function f of x equals x plus 1, and you were to consider then the limit of this function as x approaches 0, we want to locate 0 on the x-axis. And again, this is not saying that we're looking at the value of the function at 0, which happens to be 1. What we want to think about instead is, what if we start somewhere to the left of that point on our graph here, and we just follow along it until we get near x equals 0. And we do the same on the right side and follow along it until we get near x equals 0. The question we're considering is, can we find a value, a y value, that these both seem to trend toward? And the answer is yes, they both head toward 1. So that's going to be the limit in this instance. So we put that in. And again, in this example, it just so happens to also equal the value of f of 1. In the second example here, something different happens. So again, we're going to be able to find the limit. Notice that for this function, f of 0 is equal to 0. And we're going to find out that that's not the limit as x approaches 0. So if I, again, consider the value x equals 0, so just thinking about this graph here, I want to start to the left of that value and follow along my curve to see what y value I'm approaching. And now I'm going to do the same thing starting on the right and trending toward that. And in both instances, I seem to be approaching the value y equals 1, which I should have labeled here. And that's not the same as the value of the function at 0. So the limit is giving us a different way of looking at this. There we go. Put this back. So we do get, again, in this instance, 1 for the value of our limit. So at the beginning of this video, I made a reference to coming from both sides. And so we do have notation that we can use if we just want to focus on one side. If I'm approaching from the right, the way I'm going to indicate that is I'm going to put on this superscript on the x value of interest of a plus. That's going to indicate traveling from the right of c. So notice that we're indicating the values that we're considering are all values larger than c. If instead I want to come at it from the left side, I'm going to use a minus in this superscript. And again, that means that we're approaching that from values that are smaller than c, or to the left. And so I could kind of give more meaning to the idea of the limit that we presented previously by saying what we really want is, we're going to say that the limit is L and that it exists if both the limit from the left and the limit from the right are L. And so if you look back to our examples, that's kind of exactly what I was demonstrating with the highlighted part there. I approached from the left, I approached from the right, and only because I approached the same y value in those cases was I able to fill in the limit here of 1. Again, kind of looking at some examples, I have a piecewise defined function here. So again, I want to consider the limit as x approaches 0. And based off of the sides that we were talking about just above here, let's start by just looking at what that would be approaching from the left, the right, and then what we may or may not be able to consider. So in this instance here, what we look at is, let's see, back. If I were to travel from the left toward x equals 0, I'm going to follow this part. What we see here is we're approaching the y value 1. So that's what I'm going to fill in, not with that color, right? That's what I'm going to fill in this blank. Now, if we do the same thing but approach from the right, notice that the y value we're approaching is instead 0. So that's what I'm going to fill in here. These don't match. So the limit from the left I can find and the limit from the right I can find. But when they aren't approaching the same thing, that's when we say the limit doesn't exist. And so we can use a D and E for that. And so another picture, same kind of setup. So again, let's focus on approaching 0 from the left and from the right. So from the left, that puts me on this piece of the function. And what's happening here with the function 1 over x, we say that this limit approaching from the left is actually minus infinity. So notice that the idea is that if we were going to get closer and closer to x equals 0, we're only going to get a smaller and smaller y value. And there's really no reasonable cap on how small that can get. Likewise, if I follow this from the right, it seems that this is going to be as large as we could possibly want. And so that's an example where we say the limit is approaching infinity. And again, these are not approaching the same y values, kind of the opposite ends here. So we yet again see that the limit does not exist. And then my last example in this group, if instead I have f of x equals 1 over x squared, and I kind of approach this just like I did the previous two graphs. Approaching from the left, we see a positive infinity as the limit. Approaching from the right, we see positive infinity. And so here, when I'm thinking about just the limit as x approaches 0, these match. These are both approaching positive infinity. So that's going to be my limit. So the other thing that might not be clear from the examples I've done before is we can take limits as x approaches, not just say 0 or even just some, 5, negative 10. We can also consider approaching infinity. So the idea there is that we could think about if we let x get larger and larger and larger, what does it look like the y value is approaching? The same idea holds if I want to approach negative infinity for x. We can think if we let x get as small as we'd like, what y value are we approaching? So if I come back to this very same function, but instead of thinking about the limit here as x approaches 0, if I were to think what's the limit as x approaches infinity, well, I could come back to this graph and instead think about this direction. And notice that it seems that it'll just get closer and closer to the x-axis, which means that the limit here is 0, y equals 0.